So this is our second problem on indeterminate frame. We'll follow stiffness method. The very first step of this method is to find out the fixed end moment. So uh, we'll do that. So very first step is to find out the fixed end moment. For that, we'll make our joints, every joints fixed. So let's say this joint is fixed. Later, for the loading here for keeper feet, we'll got some moments and reactions. So applying the formula for which is WL squared, where L is 18, WL squared divided by 12, we'll get a moment of 108 cube feet. So this moment and this moment will be 108. We'll get a vertically upward reaction. We'll get vertical upward reaction of 4 multiplied by 8 divided by 2. That will be 36 kick. Uh, so after getting the fixed end moment, we will rotate support A. We'll rotate support A at around 0.03 radian, and we'll make it settled down 0.15 feet. Later, we'll move support D to the right at a distance of 0.2 feet. For that, we'll get moment. So let's do them one by one. Our second step is to follow the conditions, which is to rotate support A. We'll rotate support A anti-clockwise. Then we'll apply theta A as negative 0.03 radian when we'll find out the numerical value. But to formulate it, we'll rotate it anti-clockwise. For that, for that, for that, oh, it's not working. For that, we'll rotate it anti-clockwise. For that, we'll get a deflected shape. It will make a 90-degree with the support, and it will become uh, like that here. So the shape will be like that. There will be no other deflection at anywhere, because at point B, the uh, it is maintaining 90-degree with the joints, and it will not affect C as well. So here we will get a moment. We'll get a moment. We'll get a moment. Let's say that will be like that, anti-clockwise, as we formulated it, and the moment will be here 4 for the left hand, 4 E I over 18 theta a. The rotation here, the theta a will be negative because we rotated it anti-clockwise. For that, the formula is like that, but the theta a is negative because it should be actually moved clockwise. So the theta a will be negative, and here the value will be twice E I theta a over 18, half of it, and the reactions will be clockwise here, and the value will be 6 ei theta a over 18 squared. So later, it is actually the application of theta a. We will apply other thing. We will apply other thing, that is, let's make a copy of it here, align it. Later, So the next thing is to the next thing is to the settlement of point A. It will settle down. So if it settle down, it will come somewhere like here, and it will make a like this shape, and it will uh, maintain this at this support. So the overall shape will become like that. And let's say that it settles down at a depth of say delta A. For that, we'll get some moments. It settles down clockwise, so for that we'll get a moment anti-clockwise, and for that we'll get a equal moment, which is 6 ei over 18 delta A, and we'll get a reactions of we'll get a reaction of and it was clockwise, so reaction will be anti-clockwise, and the value will be 12 ei over 18 squared. Sorry, it will be 18 cubed, and it will be 18 squared. 18 cubed as per the formula. 18 cubed delta A. Sorry, it has become A. It will be delta A. So it's the settlement delta A. Second condition. We have another condition, which is the support D will move 0.2 feet right way. So we'll bring that. Let's bring it here. I don't know why, but it is going out of the screen. Disappointing. Well, for that D, let's say it has come over here. So it will maintain this shape as support, and it will make this shape at this support. So the overall shape will become like that. It has moved anti-clockwise. For that, we'll get a moment of clockwise, and the moment will be and the moment will be 6 multiplied by twice ei. Here the ei was twice ei over 16 squared del of d, and the reaction will be like that, which is anti-clockwise, and the value will be 12 multiplied by twice ei over 16 cubed del d. So it is due to the displacement of support d. The moments and reactions are like this. So now we'll apply our doki. So how many dokis we can apply here? Now let's go upward and see. So here we can apply a doki here, uh, E1, and I can apply a doki U2 at joints B. So these are the possible dokis which are rotations we can apply at point B and C. So now let's apply our dokis. So let's bring it here. Oh God, where is lagging? Well, let's apply our doki E1 is equal to 1 unit rotation. So E1 would be place something like over here. Why it's lagging? Oh God. For the application of E1, let's say it is actually anti-clockwise. Uh, to make it anti-clockwise, it will actually move. The shape will move like that. To maintain a 90-degree shape here, it will be like that, and it will be like that, and the overall shape will become like that. Now we'll get some clockwise anti-clockwise moment here. It will be anti-clockwise moment. Here we will get anti-clockwise moment, and the value will be here 4 ei over 14 e1, and here it will be twice ei over 14 e1, and the reactions will be here. For that, it will come downward and it will come upward, and the value will be 6 ei over 14 squared u1. So it is due to the application of Doki u1. Now we'll apply our Doki u2. For that, let's bring it here a little bit here. Well, a bit down. Perfect. Now, if we apply our Doki u2 right over here, how it will behave? The support will move anti-clockwise and it will become something like that. To maintain a 90-degree shape, initially it will be like that, and here this at support A it will be like that. So overall shape here it will be like that, and here it will make another 90-degree shape like that, and uh, it will act like a fixed support, and it will make a shape here like that, and here it will follow a shape like that. So the moments we'll be getting will be here anti-clockwise moment, here anti-clockwise moment, and here the value will be, here the value will be 4 ei u2 over the length, which is 14, and here it will be twice ei u2 over the length 14. Here it will be anti-clockwise, so it will be like that, and it will be like that. So here it will be 4 ei u2 over the length, and the length was 18, and here it will be the half of it, which is twice ei u2 over 18. Here it will become anti-clockwise. To make it anti-clockwise, it will go like that and come like that. So here it will be 4 multiplied by twice ei, because it was twice ei u2 over the length, and the length was 16, and it will be half of it, twice ei u2 over 16. What would be the reactions? So here the reactions will become like that. It will go like that, and it will come like that, and for that the reactions will be 6 multiplied by twice ei multiplied by u2 over 16 squared. For that the reactions will be upward and downward, and it will be 6 ei u2 over 18 squared. For that it will be upward and it will be downward, and it will be 6 ei u2 over 14 squared. So these are the moments and reactions for the application of Doki u2 is equal to 1 unit rotations. So now we'll form equilibrium reactions. We have two unknown, which is E1 and E2. For that, we'll have two equilibrium equations. So where we will apply our equilibrium equations. We'll apply our equilibrium equations where we applied our Doki. So we applied our Doki at point B and C. So let's say at point C, summation of moments at point C will be 0. So what do we mean by summation of moments? So external moments will be equals to internal moments. So at point C we had no external moments, so it was 0. So what were the internal moments? So we'll see that. So let's see, at point C here, we have no internal moments for fixed end moments, no moments for theta A, no moments for delta A, no moments for delta D. Yeah, we have some moments for E1 is equal to 1 unit rotation, and the value is 4 EI over 14 multiplied by U1. So this is one thing, and another thing is twice EI U2 over 14. So these are the two moments we will get. So these are the two moments, which is 4 EI U1 over 14, 14 plus twice EI over 14 U2. So this is the equilibrium equations we'll get at point C. So if we apply our second equilibrium equation at point B, what will be the equilibrium equation? We have the external moments. So the external moments will be 0. So what were the internal moments for fixed end moments? For fixed end moments, we go to reactions of 108, 108 clockwise. So the 108 will be negative. We have got some reactions for theta A. Theta A, the moment was twice EI theta I over 18. We have some moments for delta A, that was 6 EI over 18 square delta A. We have got some moments for del D, and the moment was this 6 twice EI over 16 square del D, and it was clockwise, so it would be negative. We got some moments for E1 is equal to 1, and the moment was twice EI U1 over 14. We got some moments for U2. We got four moments. One is 4 EI U2 over 18, 4 EI U2 over 14, 4 multiplied by twice EI U2 over 16. So 1, 2, 3. We got three moments for U2. So let's write them one by one. So first of all, we got negative 108 because it was clockwise. We got twice EI over 18, and it was actually for theta A, and the theta A was negative minus negative 0.03. We got some moments for the downward displacement of downward displacement of A, and it was 6 EI over 18 squared, and the downward displacement was 0.15. We got some moments for the displacement of support D, and it was negative 12 EI over 16 squared, 16 squared multiplied by zero point 0.2. And we got some moments for the application of Doki E1. It was twice EI E1 over 14. You can go and look it back. We got some moments for the application of U2. It was 4 EI 14. It was 4 EI over 18, and another one was 8 EI over 16. It was for U2. So this was our second equation. You can solve it for U1 and U2 using calculator, and you will get a value of U1 is equal to negative 0.0227, and here you know actually the value of E1, which is 4,000 keep feet squared. You will replace the value of EI, you will replace the value of theta A and everything. So you will get a value of U1 and you will get a value for U2, and the value was positive 0.0454. So these are the value for U1 and U2. Let's say you want to find out the value of moment AB, for an example AB. So for moment AB, what you will do, you will go here. You got actually no moments. You actually moment AB. Sorry, you actually got a moment of 108 anti-clockwise. So you'll get a 108 positive moments for fixed end moments. You'll get a moments for theta A, and it was 4 EI theta A 18. You will get a moment for delta A, which was 6 EI 18 square delta A. You'll get a moment. You'll not get any moment for delta D. You'll not get any moment for U1. You'll get a moment for U2, which is twice EI U2 over 18. So let's use these values: 108 for fixed end moments plus 4 EI over 18 theta A. You know the value of theta A, which is minus 0.03, and you got a value of negative 6 EI delta A, and you know the value of delta A over 18 squared. Will that be negative? Let's go delta A, delta A. Where is delta A? For delta A, it's clockwise, so yeah, it will be negative. And the value of delta A is equal to 0.15 feet. And for Doki U2, you'll get a moment of twice EI over 18 U2. You know the value of U2, which is 0.0454. You know the value of EI, and ultimately you will get a moment of 90.4 keep feet. So this is how you do the math. You find the moments, you can find the reactions following the same rule, which is the imposition of moments and reactions for everything: Doki, friction moments, displacement, rotations, everything. So this is all from this lecture.